I want you to make a decision right now. Not a big one, a small one, completely trivial. Pick a number between 1 and 10. Any number right now. Go ahead. You picked 1 or 7 or 3. You thought about it for a fraction of a second. You felt something that seemed like deliberation, something that felt like a genuine choice being made by a genuine choosing agent, and then a number appeared in your mind. Now I want to ask you something. Did you actually choose that number? Or did a sequence of electrochemical reactions in your brain, reactions that were themselves the inevitable product of prior electrochemical reactions, which were the inevitable product of the neural state of your brain a moment before, which was the product of everything that had ever happened to you, which was itself the product of the laws of physics operating on matter that has been evolving in a completely determined way since the first microsecond after the Big Bang? Did that sequence simply produce a number, while the part of you that experiences things invented a story about having chosen it? You felt like you chose. You experienced something that felt exactly like free decision-making. You felt the presence of alternatives. You felt that you could have picked any number, that your will was genuinely free, that something called you was genuinely in charge of what happened next. Physics is not so sure about that feeling. And the more carefully you look at what physics actually says, not physics as a vague cultural force, not physics as a philosophical argument, but the hard mathematical structure of the laws that govern every particle in the universe, including every particle in your brain, the more difficult it becomes to see where genuine freedom could possibly be hiding. I'm Leonard Susskind. I've spent 50 years looking carefully at the laws of physics, and I want to walk you through what those laws actually say about the thing you experience as free will, not to depress you. Not to tell you that nothing matters, but because the truth of what physics says about this question is strange enough and important enough that you deserve to understand it clearly. The answer may not be what you hope, but it is, I think, one of the most important things physics has to say about human existence. Let us start at the beginning, with the framework that made the problem unavoidable. In 1687, Isaac Newton published the Principia Mathematica, 3 laws of motion and a law of universal gravitation, simple, elegant, completely deterministic. What Newton showed was that the universe operates like a machine. Given the position and velocity of every object at any moment in time, the future evolution of that system is completely precisely mathematically determined. The laws of physics take the present state of the universe and calculate the future state. No ambiguity, no room for deviation, no possibility of anything happening differently than the equations predict. This was an extraordinary intellectual achievement. It explained the orbits of planets. It predicted the behavior of cannonballs, pendulums, tides. It gave humanity the ability to calculate the positions of celestial bodies centuries into the future with stunning accuracy. Newton's mechanics was the most powerful predictive framework science had ever produced. But it had an implication that Newton himself never fully confronted. If the laws of physics are deterministic, if knowing the present state of the universe perfectly allows you to calculate the future perfectly, then the future is not open. It is fixed. Every event that will ever happen is already determined by the state of the universe at this moment, which was determined by the state of the universe a moment before, which was determined by the state of the universe at the Big Bang 13.8 billion years ago. In 1814, a French mathematician and physicist named Pierre-Simon Laplace made this implication explicit. He described a hypothetical intellect, now known as Laplace's demon, that knew the precise position and momentum of every particle in the universe at a single moment. This intellect, Laplace wrote, would be able to calculate the entire future of the universe with perfect accuracy. Nothing would be uncertain, nothing would be unknown. The future would be as available to it as the past, including the movement of every atom in every human brain, including every electrochemical signal in every neuron, including every thought, every decision, every action, every word spoken, and every word left unspoken by every human being who would ever live. If Laplace was right, then from the moment of the Big Bang, the number you just picked was already determined, not because someone planned it, not because fate is real in some mystical sense, but because you're made of particles. Particles obey laws, and those laws had already calculated long before you were born, long before the Earth existed. So in the sense, long before the sun ignited exactly which electrochemical pattern would form in your neural tissue at the precise moment you thought you were choosing, your experience of deliberation was not wrong. You experienced it. It happened. But whether it was causally responsible for the outcome, whether there was genuine openness, genuine freedom in the moment of apparent choice, that is what physics puts in doubt. Now, you may already know the standard response to Laplace, the response that has comforted a great many people who were troubled by the demon. The response that says quantum mechanics saves free will. Here's how the argument goes. Quantum mechanics is not deterministic. In the classical picture, particles have definite positions and momenta at every moment. In quantum mechanics, they do not. A particle does not have a definite position until you measure it. Before measurement, it exists in a superposition, a spread of possible states, each with a certain probability. And when measurement occurs, the wave function collapses to one specific outcome. And this collapse is genuinely, irreducibly random. Not just unpredictable because of ignorance, actually. Fundamentally, indeterministically random at the level of basic physics. This randomness is not a matter of hidden variables we have not yet found. In 1964, the physicist John Bell showed that any theory which reproduces the predictions of quantum mechanics cannot be based on pre-existing hidden variables. The randomness is real. Particles genuinely do not have definite properties before they are measured. The universe is not deterministic in the classical sense. So perhaps this is where freedom lives, perhaps quantum indeterminacy, genuine, irreducible randomness at the foundations of physics, provides the metaphysical room that free will needs. Perhaps decisions are not determined in advance. Perhaps the wave function of your brain contains genuine indeterminacy that makes you free. This is a seductive argument, and I understand why people find it reassuring, but I think it fails. And not for subtle reasons. It fails for a reason that becomes obvious the moment you ask a simple question. How does randomness give you freedom? Think carefully about what quantum randomness actually is. A radioactive atom decays at a random time. A photon passes through a beam splitter and takes one path or the other with some probability. An electron measurement produces one outcome or another based on nothing, no prior cause, no hidden information, just genuine, irreducible chance. Now suppose your brain's decision-making process incorporated quantum randomness. Suppose the firing of a particular neuron, the one that ultimately triggers you to reach for coffee rather than tea, was genuinely, irreducibly random at the quantum level, undetermined by any prior cause. Does that make your choice free? No. It makes it random. And random is not the same as free. It is not even close. A choice that happens for no reason, with no cause driven by nothing, that is not free will. That is noise. That is the universe flipping a coin at the bottom of your neural architecture, and you experiencing the result as a decision. Free will, in any sense that actually matters to human beings, is not about randomness. It is about deliberating, weighing options, being guided by values, desires, beliefs, and commitments. It is about the self being in charge of the outcome. Randomness at the quantum level does not provide that. If anything, it replaces one kind of non-freedom, determination by prior causes, with a different kind of non-freedom, determination by pure chance. Quantum mechanics does not save free will. It just replaces one problem with a different problem. But the most disturbing challenge to free will does not come from Laplace's demon or from quantum randomness. It comes from a direction that most people never think to look. It comes from neuroscience and from a series of experiments that are, if you take them seriously, the most unsettling set of results in the history of science. In 1983, a neurophysiologist named Benjamin Libet at the University of California, San Francisco ran an experiment that changed the way the relationship between brain and mind has to be understood. The setup was simple. Volunteers sat in a chair with electrodes attached to their scalps, measuring the electrical activity of their brains. In front of them was a clock, a dot moving in a circle, completing one rotation every 256 seconds. Their instructions were simple. At some point during the experiment, whenever they felt like it, they should spontaneously flex their wrist, and they should note the position of the dot on the clock. At the moment, they first felt the urge to move, the moment they became consciously aware of the decision to act. Libet then compared three things. The moment the wrist actually moved, the moment the subjects reported first becoming consciously aware of the decision to move, and the moment a particular pattern of electrical activity called the readiness potential appeared in the brain. The readiness potential is a slow buildup of electrical signal in the motor cortex that always precedes voluntary movement. It had been known since the 1960s. What Libet wanted to know was when it appeared relative to conscious awareness. The results were deeply, profoundly, uncomfortably clear. The readiness potential began on average 550 milliseconds before the wrist moved. That is more than half a second of unconscious neural preparation before the action occurred. The subjects reported becoming consciously aware of the decision to move approximately 200 milliseconds before the movement, which means the brain had been preparing the action for 350 milliseconds, more than a third of a second before the person became conscious of having decided to do it. The brain acted before the mind decided. The decision appeared in the brain in measurable physical electrical form before it appeared in consciousness, before the subject experienced any sense of deciding, before anything that could be called a conscious choice had occurred. The conscious experience of deciding the thing that feels so immediate, so obviously the cause of what follows, was not the origin of the action. It was a late arriving report about something that had already been set in motion by unconscious neural processes that preceded awareness entirely. You do not decide to act, and then your brain executes the decision. Your brain prepares the action, and then your consciousness becomes aware of it and constructs automatically and immediately and without any sense of fabrication the story of having decided. This is not a philosophical argument. This is a measured, replicated, experimentally confirmed fact about the timing of neural events. The beginning of the readiness potential precedes the conscious decision to move by at least half a second, and often by much longer. The brain acts before the mind decides. Now, Libet himself was not fully comfortable with this conclusion. He suggested that, although the unconscious brain initiates the action, consciousness might retain a veto, the ability to suppress the movement in that 200 millihatter window between conscious awareness and actual movement. A kind of last-minute freedom, even if the initiation was unconscious. It is a generous interpretation, and perhaps it saves something, but notice what it concedes. The initiation of action is not conscious. The deliberation, if it occurs, happens after the process has already begun. Consciousness in this picture is not the author of decisions. It is at most an editor with limited power to suppress what the unconscious has already written. Now let me bring this back to physics, because this is where Susskind's perspective becomes central. Your brain is made of atoms, roughly 7 billion of them. Those atoms are made of protons, neutrons, and electrons. Those particles obey the laws of quantum mechanics and general relativity without exception. They do not take breaks from the laws of physics because they happen to be arranged into a brain rather than into a rock. Every electrochemical signal in every neuron, every firing of every synaptic connection, every change in ionic concentration across every cell membrane, every single one of these processes is a physical process, a rearrangement of atoms and fields governed by the same equations that govern everything else in the universe. This means that whatever Libet's experiments show is happening in the brain, it is happening in a physical system. A system whose behavior is in principle, even if impossibly complex in practice, determined by the laws of physics operating on its physical state. The question of free will is therefore not just a question about psychology and neuroscience. It is a question about whether the laws of physics as we understand them leave any room for something that could reasonably be called genuine freedom. And when you look at the laws carefully, the room appears to be very small or possibly non-existent. In classical mechanics, as we saw with Laplace, the laws are fully deterministic. The future is fixed. No room for freedom. In quantum mechanics, the laws introduce irreducible randomness. But as I argued earlier, randomness is not freedom. Random neural firing is not will. It is noise. The only serious escape route is what philosophers call compatibilism, the view that free will and determinism are not actually incompatible. That when we say a choice is free, we do not mean it is uncaused. We mean something more like it arises from our own desires, values, and reasoning, rather than from external compulsion. A choice made because of who you are and what you want. Even if who you are and what you want is itself the product of prior causes, that choice is free in the only sense that actually matters. The preferred solution to reconciling possibly deterministic physics and seemingly free personal choices is a position known as compatibilism. Whatever the fundamental particles and forces might be doing at the subatomic level, the compatibilist says human freedom can still exist because we live our lives in the macroscopic world where very different rules apply. This is actually a respectable philosophical position, and I do not dismiss it. There is something genuinely important in the idea that freedom is about the relationship between the decision and the self that makes it about whether the causes of action run through your own values and reasoning rather than bypassing them. But compatibilism requires accepting something that many people find deeply uncomfortable. It requires accepting that the feeling of genuine openness, the sense that you could really and truly have done otherwise, the future was really and truly undetermined in the moment of choice, is not a reliable guide to the physics of what is actually happening. The feeling of freedom is real. The experience is genuine. But the physics does not guarantee that the feeling corresponds to what it feels like it corresponds to. There is one more layer to this that I find particularly important, and it connects the free will question to some of the deepest ideas in modern physics. The holographic principle, the idea that the information describing the physical world is encoded on a lower dimensional surface, has a consequence that is rarely discussed in the context of free will. If the three-dimensional world, including every physical process in every brain, is a projection from a two-dimensional boundary, then the physics of that boundary determines everything that happens in the projection, including every electrochemical process, including every decision, including every moment of apparent deliberation. The projection is real. It is not fake, but it is completely determined by what is written on the boundary. There is no room in the structure of the holographic principle for something inside the projection to reach outside the laws governing the projection and inject genuine freedom from outside the causal structure. Everything that happens in the projection, including the activity of human brains, is what the boundary physics looks like from the inside, and the boundary physics is governed by laws, precise, mathematical, unyielding laws. This does not tell us something new about free will that we did not already suspect from classical mechanics, but it deepens and sharpens the case. It suggests that the determinism of physical law is not just a property of one particular theoretical framework, it is a structural feature of how physics works all the way down. So where does this leave us? I want to be honest about what I think and equally honest about what I do not know. The physics is clear that the feeling of free will is not a reliable guide to the causal structure of the universe. Classical mechanics says the future is determined. Quantum mechanics says the future is random but not free. Neuroscience says the brain initiates action before consciousness is aware of deciding. The holographic principle suggests that everything in the three-dimensional world, including every decision, is determined by physical laws operating at the boundary of reality. There is no obvious place in this picture where the kind of free will that most people believe they have, genuine openness, genuine alternative possibilities, the genuine ability to have done otherwise in exactly the same physical circumstances can be located. What I can say with confidence is this: the experience of free will is one of the most robust and persistent features of human consciousness. You cannot live as if you have no freedom. You cannot make decisions, plan for the future, hold yourself and others responsible, build relationships, pursue goals. None of it is possible without operating as if free will is real in some meaningful sense. Whether that experience corresponds to something genuine in the physics of the brain, whether there's real freedom hiding somewhere in the complexity of 100 billion neurons operating at the edge of quantum indeterminacy, I cannot say with certainty. Neither can anyone else. This question sits at the boundary of what physics currently knows. What I can say is that the default assumption, the naive assumption that you are a freely choosing agent floating somehow above or outside the physical processes of your brain, directing those processes by pure autonomous will, is not supported by the physics, not by classical mechanics, not by quantum mechanics, not by neuroscience, not by the holographic principle. The laws of physics produced you. They produced every thought you have ever had. They will produce every thought you will ever have. Whether there is genuine freedom inside that process, whether the laws leave room for something that deserves to be called real choice, is one of the deepest questions that exists at the intersection of physics, neuroscience, and philosophy. I do not know the answer, but I think the question is important enough that not asking it, assuming the answer without examination, living inside the feeling of freedom without ever confronting what physics says about that feeling, is a kind of intellectual mistake. You picked a number between 1 and 10. You felt like you chose it. Physics is not sure you did. And sitting with that uncertainty, really sitting with it, understanding why the uncertainty is there and what it means and what it does not mean, that I think one of the most important things a careful person can do with their mind, even if in the end the decision to do it was made for you.